One of the most important features in Cycle is the concept of morphing. Wave shapes, filter curves, and envelopes have the ability to morph, and by that I mean their shape can transform as the modulation source changes, like the mod wheel. Before I describe the way it works, let me demonstrate how easy it is to implement in a preset, because this will take a couple of minutes to explain. To begin with, let's look at morphing just over time. Imagine the wave shape of a pulse width modulation sound where the pulse width expands and contracts. The two shapes to transform between look like this. Each of the points in the curve has two states to be in. Basically, a state is a point's x and y position plus a sharpness value. Now suppose that we decide this sounds too thin in the higher notes. In fixing this problem, we want to change the wave shape so that in the high end of the key scale, the starting pulse width is wider. But to accommodate that, we need 4 states of the wave shape, 2 at the bottom of the key scale and 2 at the top. So now the sound is better adjusted across the keyboard. Well, that's great, but Cycle wasn't designed just to make a single type of tone in one preset. The way it stands, the preset doesn't have any range of tonality like musical instruments have. We might want to control the brightness of the sound in this preset. To reduce high-frequency content in the wave shape, we would decrease the sharpness value for each vertex and separate the closest points by a bit. Because we still want to keep the ability to morph with time and key scale, we need another 4 states. So in total, the 3 morphing ranges of time, key scale, and modulation form a network of 8 states arranged like the corners of a cube. I call this a vertex cube, and one of these corresponds to each point in a curve. For the time range, the current value is the duration that the note has been held as a fraction of the total preset duration. For key scale, the current value is where the note is as a fraction of the keyboard range, so a note at middle C will have a key scale value of about 0.5. The current modulation value is set by the mod wheel, or whatever modulation source you've chosen. These 3 values, which can change during the playback of a note, make up what I call the morph position. For the points that make up a curve, each is the product of a weighted combination of those 8 states, and the weighting is determined by the morph position. When the position is closer to one vertex at any corner, that vertex gets weighted more, and the ones further away get weighted less. Notice that the buttons are color-coded to the position sliders. The use of yellow for time, red for key scale, and blue for modulation is consistent throughout the interface. Because Cycle uses proximity selection, to select a particular state of the cube, you move the graphic morph position to one end of the range, and then select the curve point. If linking is enabled for a range, then you'll move both ends at once, but if it's disabled, you only move the end that is closest to the morph position. Keyboard shortcuts make it quick to move the morph position to either end. Back to the Cycle interface, the linking buttons let us choose which states to move in unison during the editing process. The normal behavior when a point is moved is to move all 8 states together, and that is because you wouldn't really want to duplicate every edit 8 times over, especially when you're just experimenting. On the other hand, when you deliberately want to make the curve dynamic across some range, that's when you deselect linking for that range. In the 3D windows, you see 2 ends of one range at once. The default range, or morphing dimension as I sometimes call it, is time. You can change which dimension you see by clicking one of the prime axis buttons. These set the x-axis shown in the 3D windows. Set the prime axis button to keyscale and we can see the wave shape, spectrum, and envelope as they change from low to high notes. The 3D envelope view shows up when you switch away from time as the primary axis. This is because envelopes only morph along keyscale and modulation ranges. In particular, morphing the scratch envelope is a very powerful feature because it makes it easy to totally transform a sound. Well, that's probably enough about morphing for now. So with that, I hope this helped, and thanks for watching.